Hello students, in this session we shall discuss the sign convention of the chapter 10 of class 10 science. In the previous session we have done the ray diagrams. Now before starting this you need to clear about the ray diagrams. How the image is formed in case of mirror, spherical mirror and spherical lenses. You have seen already and you must be clear about all this. Otherwise you will feel some problem while doing the numerical sums. Anyway, you see, here I have drawn sign convention is very easy, just try to understand. Here I have drawn a concave mirror. A concave mirror is placed and you know this is the principal axis. Okay, this is the principal axis, and this system to determine the sign convention. Sign convention is nothing but the what would be the sign of the image distance, object distance, focal length, etc., etc. And that sign will indicate the direction only. So this to know it better and to know it easily, let's compare this system with our Cartesian system. Cartesian system, that means the coordinate axis and the graph we have done in the earlier classes. So you know about this. You have done in class 9 also. See, this is x-axis and this is y-axis, and this is the origin. In the right side, this is the positive x, and this is negative x, this is positive y, this is negative direction of y. So same thing is applied here. Here mirror or lens may be anything. Here I have placed concave mirror, it may be concave. I have placed concave mirror, it may be convex mirror, concave lens, or convex lens. Whatever be the lens or mirror, the sign convention will remain the same. See, pole, we should consider the pole as the origin in case of mirror, spherical mirrors, and we shall take the optical center as the origin in case of spherical lenses. Now this pole we shall consider as the origin. Now see, this part is the positive direction according to the Cartesian axis. This is the negative, this is positive, this is negative. So usually we place the object here in case of concave mirror. So as the object is placed in this side, so it is always, usually it is negative because this is the negative direction of x-axis in all cases. And if the object image is formed here in this side, then it will be positive in case of real and virtual and erect. Otherwise, if it is real and inverted, then it will also be negative because this image formed in this side. So depending on the ray diagram, you can understand this. And object is placed above the principal axis. So above the principal axis is positive. So this height of the object will be positive always. And in case of real and inverted, those will be negative. All right. Now see, here U is the symbol. It is usually denoted as the object distance. And V is taken as the image distance. F is the focal length. Alright, these are the parameters. You know this. These are the symbols. Now another parameter is there which is required for the magnification. Magnification is very important quantity in case of sign convention, and the mirror especially in case of mirror formula and lens formula. Now see, how does magnification depends. You see, this m is called the magnification. M equal to minus V by U. Minus V by U equal to H dash by H. This is in case of mirror. Okay. and in case of lens it is m equal to v by u equal to h dash by h. Now what are h dash and h? H is the height or size, height or size of object, and h dash equal to height and size of image. Okay, so this way the magnification varies. Now magnification when a negative sign, when magnification takes negative sign, or if you get the value of m has the negative sign, then it indicates the image is real. By looking at the value of the magnification or value of the m, we can decide what type of image is. Then image must be real. And if the value of the m is positive sign, then that magnification will indicate the image as virtual. Okay, if the value of m we got the positive, then we have to understand the image formed is always virtual. This way magnification depends or relates to the image form. Now there are two formula for mirror. It is 1 by v plus 1 by u equal to 1 by f. This is called the mirror formula. The relation between the UVF, image distance, object distance, and the focal length of a mirror. And similarly, in case of lens, there is also a relation 1 by v minus 1 by u equal to 1 by f. This is called lens formula. Alright. Now we can take an negative example to illustrate this. Say I am just simply doing the sum from your exercise. It is 11, number 11 I am doing from exercise. You can refer it from your book. You see a concave lens of focal length is 15 centimeter. 15 centimeter forms an image 10 centimeter from the lens. How far is the object placed from this lens? Before starting, you must understand the question properly. Well, one more thing I'd like to say about the focal length. You just in case of focal length, you remember when it is a matter of concave, whether it is a concave mirror or concave lens, the focal length is always negative. I repeat, when it is a concave mirror or concave lens, the focal length is always negative, else positive. That means in case of convex mirror or convex lens, the focal length is always taken to be positive. Okay. So here I can write like this. You see, focal length is negative in case of concave lens. Sorry, concave mirror and lens both. And focal length is positive in case of convex mirror and lens. Now start the 11. Now see here, focal length is given and lens is given, concave lens. So definitely we can write given f is equal to minus 15 centimeter. Alright. Then forms an image 10 centimeter from the lens. That is, image distance is given and image distance is represented by v. Now in case of concave lens, where the image is formed this side. You can see the ray diagram. That means in the negative side. So this must be negative. V is equal to 10 centimeter. That's why I already in the beginning I told you that you must be clear about the ray diagram. Well, you see this in diagram of concave lens. In both cases, this is actually case of infinity, but if this is the popular case, you see the image object is placed here and image is formed here. So both in the same direction, and this direction as per the sign convention is positive. Sorry, not positive, negative it is. That's why we have taken it as negative. Now we need to find the object distance, that is u we have to find. So by, as it is a length, so by length formula 1 by v minus 1 by u is equal to 1 by f. So 1 by minus 10 minus 1 by u is equal to 1 by minus 15. So 1 by u equal to 1 by 15 minus 1 by 10. Now we shall simplify to find the value of u. Take the LCM of 10 and 15. 30. So we got the value of u is equal to minus 30. Okay, so it is matched with our ray diagram. It matches our ray diagram. Object we place in this direction, so it is value should be negative. If not negative, if it is not negative, then you must think that there is some error, definitely. Therefore object distance you write here. Therefore object distance is equal to, then you can write only 30 centimeter, not minus 30, because distance cannot be taken as the negative. Distance is always positive. Minus, this minus sign will indicate the direction, remember it. Okay, minus or plus indicates the direction here. So object distance actually 30 centimeter. Okay, now next, number 12 we see. An object is placed at a distance of 10 centimeter from a convex mirror. Here the case is of convex mirror of focal length 15 centimeter. Find the position and nature of the image. Now you are to find not only position but also nature. So what are given? First you see, an object is placed at a distance of 10 centimeter. That is, object distance is given, and you know the object distance. Object distance is represented as u. So object is always placed in this side, so it is always negative. U equal to minus 10 centimeter. And focal length is given. So it is a convex mirror. So in case of convex, it is always positive. So f equal to definitely 15 centimeter. We have to find the v first. So it is a mirror. By mirror formula, we shall use the mirror formula. 1 by v plus 1 by u is equal to 1 by f. So 1 by v plus 1 by minus 10 is equal to 1 by 15. Now we shall simplify. LCM is 30. 5 by 30. 1 by 6, that is v is equal to 1 by 6. So it is a convex mirror. So in case of convex mirror, the image is virtual and erect. This side it is formed. So it is positive. So value is correct. Therefore image distance, here we should write image distance is equal to 6 centimeter. Okay. Now we have got the position. Now we have to find the nature of the image. So to find the nature, we have to take the help of magnification, as I shown you earlier. Now also m equal to it is a mirror, so it is minus v by u. You must remember this formula. In case of mirror, it is minus v by u. In case of lens, it is v by u. That you must remember. So m equal to v by u. V value of v is minus sign will be there, and value of v is 6, and value of u is minus 10. See, it is 3 by 5. So what we got? We got it is actually the result is positive. Okay, you can convert this to the decimal place also if you want. Now 0.6, this is positive. And what does the positive value of the magnification indicates? The image is virtual and erect. If it is negative, then it is real and inverted. Already I told you. And you can go through your book to find the, if you go through the sign convention part, you will get this. So positive value of magnification indicates that image is virtual and erect. Whether it is virtual or virtual and erect or real and inverted, this is called the nature of the image. When you will be asked to find the nature of the image, then you have to find find whether the image is real and inverted or virtual and erect. Remember this. Hence, the image is virtual and erect. Okay, thank you.